Hello and welcome to Notes 5.5. This is for Math 8. This note is called Solving Systems of Equations by Elimination. This is day 2. This is not the first time you've seen elimination. It is the first time you've seen elimination where let's see, both equations are, neither equation is set up for elimination right off the bat, and we will need to modify both equations to make things cancel or eliminate. We are used to only eliminating by modifying one equation. Now we have to modify both. And so I know it says that we're going to work with our partners, and we're not going to do that. You're going to work with me. I'm your partner right now. What I plan to do is to first of all look at both equations and say, which of these variables do I want to eliminate? It does not matter. We can eliminate the x's or we can eliminate the y's. Let's focus on the x's this time around, and let's eliminate those. I have a 4 and I have a 5. If you can see right here where I'm pointing with the eraser, 4 and 5. I have to think of a number that both the 4 and the 5 can be so that they can cancel. I think I could make the 4 into a 20 as well as the 5. Okay, I think I could make them both into 20. So what I'll do is I'll modify both equations so that the x is 20, but one of them is going to be a positive 20. The other will be a negative 20. So let's start out, I'll multiply equation 1 by 5. Now that would give me a 20x. What I'm going to do is multiply the second equation by something that gives me negative 20, and that's going to give me, or that's going to be negative 4. Okay, so what I have right now is I've started the modification process so that the x's will eliminate, and what I'm going to do is I'm going to turn one of the x's into positive 20, that's from equation 1, the other x into negative 20. Then they will eliminate. Now remember, when we have the number outside, when we're modifying the equations, we need to distribute. So what we have down here is, 20x, so it's 20x. Now it's going to be 3 times, let's see, 3 times 3y times 5, 5 times 3y, 15y, and the 5 times the negative 1 is going to be negative 5. Okay, let's double check now on the bottom equation. We'll distribute a negative 4 to the 5, to the positive 4, and to the 1. That should give me negative 20. And it looks like I forgot my x there in equation 1. So negative 20x minus 16y equals negative 4. Okay, now this is the same process that we've been using with elimination. We notice that the x's are lined up, the y's are lined up, my equals are lined up, and so are the constants. So we can simply add. When we add the 20x and the negative 20x, they cancel. That's what we were hoping for. 15y plus negative 16y is negative 1y, and negative 5 plus negative 4 is negative 9. I am almost done finding y. All I need to do is solve for y by undoing that multiplication. Undo the times 1 with a division by negative 1. Okay, so the negative 1s will divide out, and it's leaving me with y equals, be careful, positive 9. Negative divided by negative is positive. Okay, so what we've done here, we did find y as we've been doing in class. Now we will find x. Okay, so finding x here, it does not matter which equation I use, equation 1 or equation 2, but I do plan to use one of the original equations. So what I will do is use the 4x plus 3y equals negative 1. That's equation 1. I know that y is 9, so down here I'm going to color code this. Y is equal to 9, and that is where I will substitute in equation 1. So color code that, make that blue. Alright, so I have 4x plus 3 times the 9. Again, that's what y equals, and we are subbing in what y equals, and then we have negative 1. Now it's just solving an equation by the steps that we've used for a long time this year. 3 times 9 is 27, and equals negative 1. Let's subtract the 27 because that is unattached from the variable. The 27s, they cancel out. I am left with 4x. Negative 1 minus negative 27 is negative 28. Be careful there. If you're on a number line and you're starting out, oops, I'm off the screen. If you're on a number line and you're starting out at negative 1 and you subtract, you move to the left all the way out to 27 spots later, you're going to be at negative 28. Okay. The last step here, divide by 4 to undo the multiplication. X should be equal to negative 7. Okay? And as we've been doing in class, let's list our solution. Our solution for this system of equations is x equals negative 7, y equals 9. Or on a graph, x is negative 7. We know x comma y, so it's going to be negative 7 comma 9. Okay? So there is our first example. If you have any questions on that example, make sure to circle them, note them, and ask about those next time in class. So our solution, we said, was negative 7 comma 9. What I did was go through and double check that work. And if you would like to pause the video and just look at my check, you will see though that it does check out. So I know that negative 7 comma 9 is going to satisfy both of these equations. Now let's move to question 1. In question 1, you'll notice that it is not set up for the x's or y's to eliminate right off the bat. However, this question is slightly easier than what we just did because I only need to multiply or modify equation 1, not both of them. The reason is I notice that I have a 9x. I could choose to eliminate x's if I multiplied the top equation by negative 9. If I chose to eliminate y's, I would multiply the top equation by positive 9. That's what I'm going to do. I have a 1y. Just notice the coefficients in front of x and y are 1. If you would like to, let's actually move that parenthesis and let's put a coefficient of 1 with the x as well. Okay, let's do the distribution. 9 times 1, 9 times 1, 9 times 14. That will give me 9x plus 9y equals 90 and 36 should be 126. Let's bring down our bottom equation, negative 9y and 36. At this point, we do have the x that will add together to give us 18x. The y values, they will cancel. And down here, we will get 162. Now all I need to do is undo the multiplication with the 18, so divide both sides by 18. X is going to be 9. So what we did there was we just found x. Now, as we've been doing in class, let's find y. In order to find y, I like to use the original equations. Either equation will work. I'm going to use the first equation. If you recall, it was x plus y equals 14. If I were to replace the x with a 9, I would have 9 plus y equals 14, and subtract the 9 so we can isolate y. Y should be 5. And so our solution is going to be x equals 9, y equals 5, or 9 comma 5 on a graph. And remember, if I were to graph those equations, the lines would intersect at the point 9 comma 5. The last question of this note, over here, number 2, is going to be one of the more challenging questions that we have had in this unit. The reason is, this question is not set up right now in the proper order. Remember that I have said we need to line up our x's, our y's, our equals, and our constants. This first equation is out of order. So I'm going to modify that equation, but I'm going to modify it so this negative 2x is over here on the other side of the equal sign. Since it is a negative 2x, we know if I'm trying to quote-unquote move it, what I will do is use the inverse operation of subtraction, which is going to be addition. So I would add 2x to both sides. Again, I'm just trying to get the negative 2x to the other side of the equal sign so that all my columns line up properly. So I cannot combine 2x and 3x. I don't want to anyways. I want 2x to be in its separate column, and then my equal sign and my 5. Reminder, the 2x's, they will cancel out. Okay, now all I'm going to do is actually rewrite the system. I'll do that in a different color. My new version of equation 1 is 2x plus 3y equals 5. Now I also have my second equation, which was 5x plus 4y equals 16. Okay. Now what I notice is x's and y's, they are not set up to immediately eliminate each other. It also looks like neither the x nor the y column is going to be easily eliminated by only modifying one equation. I'm going to have to modify both equations. You can choose x or y to eliminate. I'm going to choose to eliminate the y. And so I'm looking at the 3 and the 4, and I'm trying to figure out what is a number that 3 and 4 will both evenly go into. I think the first number that comes to mind is 12. Okay, so I have to choose one of these y's to be negative 12, one of them to be positive 12. So let's go with the first equation. Let's change that into a negative 12. How do I do that? Multiply 3 by negative 4, because negative 4 times 3 is negative 12. All right, so now I'm going to be distributing. What this will give me is negative 8x minus 12y equals negative 20. Okay, now I also want the 4y to be positive 12y. So I'm going to multiply the second equation by positive 3, because positive 3 times 4 is 12. Don't forget to distribute here. So 3 times 5 is 15x. 3 times 4 is a positive 12y, and then I have 3 times 16, which is 48. At this time, after all that work, I think we are finally set up so that one of the columns will cancel, and we chose the y's to cancel. So they will cancel out, so I'm going to cross them out. Add the negative 8 and the 15x, that will give me 7x, and this is going to be equal to negative 20 plus 48 is 28. Okay, and as we always do, undo multiplication with division. X will be equal to 4. Halfway done after all of that work. So what we did here was we found x. Find x. Now what I'm going to do over here, find y. I'm going to go back into an original equation. Let's use either one. We can use the 3y equals negative 2x plus 5. And since we know that x is 4, let's just replace that x with 4. So I have 3y equals negative 8 plus 5. Okay. Combine like terms. There's a negative 3. And let's undo multiplication with division. Y equals negative 1. So our solution is going to be x equals 4, y equals negative 1, or the ordered pair 4, negative 1 on a graph. Please mark down any questions you have on this video so that when I see you next time in class we can go over them. Please stay tuned for a question on this video as well as a rating on the video. As always, I hope you enjoyed the video. I will see you next time in class.